Okay, so this is how you do problem number 11 in the chapter 9 homework. So this problem asks you for the impulse of the force, the final velocity if the particle's initial velocity is 0, the final velocity if the initial velocity is -2, and finally the average force. So here is the graph of the force times time. So the part A of this problem asks you for the impulse of the force, and because of the fact that impulse of the force is force times time, if the force were constant, in this case the impulse would be the area under this curve, or the integral of this. So J equals force times time. And what I did was I just segmented this figure into 2 triangles and 1 rectangle, but you can also solve it as a trapezoid. So once you find the area, you'll get 12 Newton seconds. The second part of the question asks you for the final velocity. So what you have to remember is impulse is also the change in momentum. So that means that the initial momentum plus the change in momentum has to equal the final momentum. So because the initial momentum was m times v initial, which was 0, this just goes to 0. So 12 Newton seconds equals 2.5 kilograms times the final velocity, and dividing both sides by 2.5 kilograms, you get Vf equals 12 Newton seconds divided by 2.5 and 4.8 seconds. Sorry, I forgot to write that down. For C, it's basically the same thing. You use the same formula, except this time the initial momentum does not go to 0, so you really have to substitute all the known values in, and if you do that, you get the final velocity of 2.8 meters per second. And finally, for D, it asks you for the average force. So what you have to keep in mind is the average force is just the impulse divided by the change in time, and these are just like different notations for that. So the impulse we solved in part A, and the change in time you can just see from the graph that it extends from 0 to 5 seconds. So 12 Newton seconds divided by 5 seconds is equal to 2.4 Newton. So that's how you do problem number 11 in the chapter 9 homework.